Thank you very much. Let's say that if we talk about safety, we should talk about storm brakes. Of course, it's known to everybody that we are facing a climate changing. So quantity of cranes are increasing and they are getting bigger. So the probability of accidents are increasing. And unfortunately, the storm brakes, which is the only thing that can keep your equipment in safe position, is always underestimated. And of course, whenever an accident happens, it's always too late. So the best way is to prevent this kind of situation, considering also that the investment for the storm brakes is only the 1% of the complete amount of the crane. So what could be your advantages to have a fully, let's say, good quality and good calculated or selected storm brakes is that you have never to worry about unexpected weather conditions like microburst, for example. You can also eliminate all the preventable incidents because with good storm brakes, you can lock down your crane in a safe position. And of course, you can save your system from accident with a very small investment compared to the whole amount of the crane. So let's start to have an overview about the systems that are used to keep the cranes in position. We should talk about speed of wind, first of all. Let's say that we have some limits. For the wind speed up to 80 kilometers per hour, the gantry brakes, like our disc brakes, are enough to keep the crane in position. When the speed of the wind is getting higher, up to 100 kilometers per hour, then wheel brakes will come in to help the gantry brakes to keep the crane in position and safe from storm. For higher speed, up to 160 kilometers per hour, because 160 kilometers per hour is usually the limit where the crane is put in parking position with a safety pin or tie down. In this case, rail brakes and rail clamps have been used to keep the crane in the safe position. Now, just a brief introduction about the type of brakes against storm that we have. This is the wheel brakes. This is the first step of the storm brakes. Up to 100 kilometers per hour, they can be sufficient. Just a note, which is important, I think, to know, is that make no sense when we calculate wheel brakes to over-dimension them. Because up to over a certain force limit, wind is getting stronger, so then the crane starts to slide on the rail because it wins the friction between the rail and the wheel. Then, of course, we have rail brakes and rail clamps, which can work, let's say, about up to 160 kilometers per hour, and they are the most common used, and the selection between one type of the other is mainly made considering the situation on the ground, like rail submerged by concrete and so on. Now, what are the most important information to know for a correct selection of storm brakes? First of all, is the crane surface. As you know, the crane is working like a sail against the wind. So we have a surface which is pushed by the wind force. So in order to offer to our customer the best solution, the first important information to have is the crane design to have a drawing is the best in this case. Then we can apply what is called from the FEM, the shape coefficient, and then we calculate the proper surface. Now, another very important information, which is, let's say, strongly related to all the other products of pinch BUBENZER, is that gantry brakes must be perfectly working and maintained, because as you can see from this easy formula, the force that you need from the storm brakes are basically the difference between the force of the wind and the force generated by the service brake, the gantry brakes. So that's clear that if we have a perfect working and functioning gantry brakes, we can easily have a big help for our storm brakes. Now, the rail profile, it's also something very important that most of the time is also, let's say, underestimated or not considered in the right way, on the proper way, because the rail clamps, even the rail brakes, are working into a certain ratio, let's say, into some limits for the rail dimension. So we must know absolutely the minimum and maximum measure of the rail. Otherwise, we risk to install something that will not work properly. Same thing is for clips or fixing system for the rail, or the rail joint, the dimension of the trench. Everything is important to be known to be sure that the offered product will work in the proper way. Now, let's say that the last point, which is very important to know, or at least one of the last, is the position of the storm brakes. Why is important? Because as everybody know, I suppose, storm brakes has floats horizontally and vertically. To define the vertical float, it's important to know where the brakes is installed, because it's strongly related to the position and to the pivot points of the bogie. Then it's easy. If it's in the middle of the seal beam, okay, you have the same distance, which is easy, because according to the FEM, we have to consider 1 millimeter of vertical float for every meter of distance between the brake and the pivot point. In case it's not in the middle, it's easy. With a very easy formula, you just have to calculate the medial value, and then we can offer consequently the right product for the right terminal, vertical float. So at the end, with all this information, we can provide the correct solution to keep the crane safe against storm, because this is, let's say, our main target, to keep your safe crane. Thank you.